But this was first and foremost a human tragedy on an unimaginable scale. It ripped away much of Japan's infrastructure. One of the world's most developed nations brought to its knees. As rescue workers pick through the debris, Billum and other scientists around the world take on the challenge of understanding the massive earthquake in the hope of one day avoiding such loss of life. The source of the disaster lay 100 kilometers off the coast. Beneath 6 kilometers of water, the Earth was distorting, a vast, slow-motion collision. The Earth's crust is made up of several continent-sized slabs of rock, tectonic plates. Japan lies on a boundary between these plates. The Pacific plate is ramming into it at 8 centimeters a year, about the same speed your fingernails grow. The Pacific plate drives underneath it, snagging and catching as it goes. The plate that Japan sits on compresses and buckles under the strain. Over decades and centuries, immense stresses build up. Shockwaves radiated out. The fastest, known as P waves, traveled at 6 kilometers a second. Japan's detection systems picked them up instantly. Within seconds, before anyone realized what was going on, automatic warnings flashed across the country. A computer-generated announcement even interrupted a Japanese parliament broadcast. By the time the warning system kicked in, the coastal city of Sendai, just 130 kilometers from where the earthquake originated, was shaking. The slower but more destructive shock waves, called S waves, had now arrived. These waves travel at 3 kilometers a second. They threw northeast Japan into chaos. "100 seconds since the fault line slipped. The slowest moving but most destructive S waves reached Tokyo. With 60 seconds warning, Tokyo was already braced. But not for this. The quake lasted an unprecedented 5 minutes. One American geologist was in the city that day.
We expected it to end after 10, 15, 20 seconds, something like that, maybe a minute at the most. About minute 3 or 4, we were just all kind of astonished that it just kept going and going and going.
What is different about a big earthquake is that it begins, but it doesn't stop.
We're just looking at each other going, is this over yet? And no, it's not, it's still going. It was kind of a growing realization that it was just getting bigger and bigger and bigger, and it had to be fairly close.
In a nearby park, an American tourist found the ground opening up at his feet. No one has ever filmed this happening before. The footage reveals a characteristic of earthquakes: liquefaction. As the ground is compressed, water is squeezed and forced to the surface.
Okay, we have earthquake right now, and this is actually moving. Can you see the cracks moving? That crack was not there. The crack is getting bigger and smaller, going back and forth. And there is water coming up all over in the park right now. This and here's a huge crack, and it's still moving. It's just going back and forth, swaying. It's making me kind of nervous. This land could just go, potentially. I don't know.
In the days to come, scientists would regrade this quake as a magnitude 9. The warning systems worked, and most buildings were still standing. But even before the quake had finished, everyone in Japan knew worse was to come. There were only minutes before a tsunami would arrive. The question now was how many would escape in time. On March the 11th, 2011, the billions Tokyo had invested in quake-proof engineering and early warning systems proved their worth. They saved the city's structures and its people. Then, the tsunami struck. The sudden upward flip of such a huge slab of rock lifted a 6-kilometer deep mass of water upwards to the surface of the sea. As it collapsed back, immense waves raced out across the ocean. Not like normal sea waves, more like shock waves from an explosion. Just a meter high, but over 100 kilometers from front to back, and traveling at terrifying speed.
The energy heaved up the sea floor. That displaced a vast amount of water that we can see made it its way on land, it made its way off around the Pacific.
One side of the wave hurtled out across the Pacific. The other side raced towards the coast of Japan. The coast offered little resistance to the wave. Tsunami warnings did sound, but here there was little time to get to higher ground.
The best early warning system people would have had would have been the fact that there was an earthquake. And people have got used to the fact that if you have an earthquake, there is a possibility of a tsunami that will follow. But in the timescale they had, there was very little time or very little opportunity for escape.
The tsunami hit Ofunato just 20 minutes after the earthquake.
Water that actually hit the coast will be well in excess of 1 billion, probably 10 billion tons of water. That's a little bit like taking 1 million swimming pools and just emptying them onto the coastal areas of northeast Japan.
15 minutes later, the tsunami hit Sendai, 116 kilometers south. The area around the city is mostly farmland, low-lying, fertile, and flat. That's why the tsunami barely slowed as it smashed ashore. The flat land was perfect for an airport, too. It opened just 4 years ago. A kilometer from the coast, it was deluged.
It hits very low-lying areas. There's nothing to stop it moving inland. And so it can move inland 6-7 kilometers without being impeded.
There's not much to slow it down, and because the wavelength of the tsunami is so big, it's not going to stop until it reaches something, reaches some sort of high ground, and it'll just keep on coming.
The tsunami breached the coastal defenses. Miyako's high walls proved useless. Countless people died here. What happened here highlights another mystery. The area had good tsunami defenses. The residents were prepared. They should have been safe. Last time a tsunami hit here was half a century ago. In the aftermath of that tsunami, they built these 10-meter high seawalls, far higher than anyone thought they would need. Tsunami drills became a regular feature of life. Everyone knew what to do when the sirens sounded. On March the 11th, all along the coast, the sirens did sound, this time for real.
Go to the hill.
A tsunami was coming. This was not a drill.
You hear the sirens?
There's a hill outside of town that we're going to try to get to. Well, it's a precautionary measure, but I mean, you know, you never know. This town has a lot of history with tsunamis and a lot of death from it, so they're taking it pretty seriously, obviously.
The warning saved the lives of some. Traveling north, at first the town of Ofanatu seemed untouched.
Look over there. Those houses look undamaged. They've got power and everything here. It's just so strange.
Closer to the shore, it was a different story.
And as if Ofanatu didn't have enough problems, scientists reckon that this whole area, this region, has subsided well over a metre. And in the next couple of days, the region is also expecting the highest tides of the year. The sea is some 500 metres down there, and yet up here we have this. It's a remarkable sight by any standards, a huge tug which has been brought all the way up here by the tsunami. And what's remarkable about it, or what's even more remarkable about it, is that what it says about the size of the tsunami. Because the Japan Meteorological Center have just produced provisional estimates saying that the tsunami that hit this region was about 3.5 metres high. Now we're 7-8 metres above sea level here, and even given the surge, the fact that it could bring that all the way up here does suggest that the tsunami here was a lot higher than 3.5 metres.
Even amidst such chaos, this seems strange. Boats, trucks and cars were dumped on top of buildings, much higher than the recorded height of the wave.
That happens because as the water's pushing through restricted areas like the streets of towns and villages, it's being effectively funneled. And the water's got to go somewhere, and so it goes up as it's squeezed and funneled and pushes material, pushes cars onto roofs, sometimes as high as 50 feet. So in areas, the impact of this will be even greater, particularly where you get narrow streets.
Once the wave starts to pick up part of a town, the warehouses along the dock, the debris and all that, then it becomes more like a glacier. You know, it's a moving wall of debris, and the more mass it has, the more power it has as it comes in. It doesn't really look like water beyond some point. It looks like the entire town is flowing in, and it is. So all the mass of all the buildings, cars, refrigerators, and everything that's in that wall It's essentially a debris glacier at that point, and it just keeps coming in.
This is Minami Sanriku, a town that was wiped off the map. "95% of the buildings destroyed. Over 10,000 people, half the population missing.
This place, Minami Sanriku, probably symbolizes the tragedy more than anywhere. An entire town wiped out by the force of nature. It's funny that when you hear that sound of an ambulance, it kind of actually gives you hope that they might have found somebody alive. Although that must be happening fewer and fewer times between. Anyone who did survive and was trapped would almost certainly have died of hypothermia by now.
At the town of Rikuzen Takata, rescue workers hunt for survivors and discover the dead.
When they find a body, they put a large stick in the ground with a flag attached to it so that it can be recovered later. It's a fairly gruesome and sad task. In fact, they're not just collecting bodies, they're also collecting personal mementos as well, which they find like this. I'm afraid what we have here is more bodies waiting to be taken away.
Journalist Callum McRae has been moved by the plight of the people here. In the regional capital of Sendai, the temporary shelters are full. But in a darkened, ravaged city, it seems one person at least is trying to cling to normality.
We're in Sendai, 300 or 400 meters from the shorefront, in a scene of apocalyptic chaos. It's cold, it's dark, there's no power anywhere. And yet, up there, in that abandoned block of flats, on the top floor, there's one light. One man, one family perhaps, trying to survive in this chaos.
In Japan, the humanitarian disaster continues. Estimates put the death toll from the quake and tsunami at over 20,000. Rebuilding will take generations. For scientists, the analysis continues. From all the data they have acquired, one threat is still very clear. Experts have warned of a large quake and tsunami off the coast near Tokyo for years. The fault lines under the ocean to the south of Tokyo are dangerously stressed. But this time, the earthquake happened in the north. The densest areas of population survived largely unscathed. Next time could be different.
One area of extreme concern is Tokyo, the world's largest city. there could be a major event in Tokyo that would be extremely damaging to this very densely populated region.
If you were going to choose somewhere to put one of the major industrial economies on the planet, that part of the Pacific Rim is not the place you would choose.
It could be happening as we speak, or it might not happen for a decade.
The critical thing is, has this particular earthquake shaken that region up so that it brings forward the timing of that earthquake?
It's foolish to think that we can stop natural phenomena. What we've got to do is to learn to live with them and minimize the consequences when they happen, and minimize also the recovery time.
It's very difficult for science to protect against earthquakes and tsunamis. What science can do is help town planners, engineers to make buildings stronger, to make designs of buildings and cities more resilient. We cannot stop these things happening. We can't prevent it, but we can prepare for it.